Good morning to all. Today we are going to discuss three concepts. In that first one, test strategies for conventional software. Second one, test strategies for object-oriented software. Third one, test strategies for web apps. Now we are going to discuss the first one, test strategies for conventional software. In this concept, it contains two concepts. First one, unit testing. Second one, integration testing. So now come to the first concept of test strategies for conventional software. Nothing but unit testing. So what is mean by unit testing? Unit testing means it's nothing but focusing on verification effort on the smallest unit of the software design. That means whatever the program or project you are developing, in that the smallest unit what you develop, if you tested that unit, it called unit testing. For example, in our syllabus, that we are not getting the total syllabus once. The total syllabus what we have, that one is divided into units. So unit 1, unit 2, unit 3, unit 4, unit 5, like that we are getting the syllabus for a subject. So if we completed one unit, then we are writing unit test 1. Then if we completed unit 2, then we are writing unit test 2. That's nothing but in the software side it is called as unit testing. If we completed in a total project, if we completed a unit, if we tested that unit, it comes under unit testing. So to explaining that one, this simple diagram is given here. So in our projects, those small units we are calling as modules. So software projects are divided into modules, small units. Inside the module, each module we may have different points, interface for that module, local structures, boundaries, independent paths, and error handling paths, etc. For all these individual concepts in that module, we write different test cases for that to test that unit. So this overall concept will be called as unit testing. And other component concepts of unit testing are as followed. In that unit testing, boundary testing is one of the most important concept of unit testing task. Why? Because means some softwares may fail at its boundaries also. So to check the boundaries of the softwares comes under boundary testing. So for this reduce the testing concepts, a good design always anticipates error conditions and establish error handling paths to reroute or cleanly terminate processing when an error does occur. That means a good design may anticipate means some before actions may be taken on error condition and establish some error handling parts to terminate the process when error does occurs. So whenever occurs, these conditions may take care. So you don't call this approach, it's called anti-bugging. Anti-bugging means before occurring the errors, if we rectify them in our projects or programs, then it comes under anti-bugging by using error handling methods. So you don't call this approach called anti-bugging. Then among these potential errors that should be tested when error handling is evaluated. So these evaluated are expressed by using some points. 5 points are there for error handling evaluation. First one, error description is unintelligible. Second one, error noted does not correspond to error encountered. And third one, error condition causes system intervention prior to error handling. Fourth one, exception conditions processing is incorrect. Error description does not provide enough information to assist in the location of the cause of the errors. So these are the 5 points which evaluates error handlings. So these are the concepts of unit testing. Then now we are going to discuss the total procedure, unit testing procedure. So in this unit test procedure, we already discussed a unit may contain some individual components inside of that unit. So for all those units, we are writing test cases. After completed the test cases for all the components in the module, we hand over that one to a driver. A driver means nothing but a main program. So this main program, nothing but driver, will test that module and its stubs. Stubs means nothing but subprograms of that modules. So inside of the module, what are the functionalities are there, and for those, what are the test cases we are written, those are all tested by this main program called driver. So this is nothing but the overall concept of unit test environment. So this is nothing but the unit test procedure. Then the second concept is integration testing. So before entering into the concept of integration testing, we need to discuss some points. What is meant by an integration testing? Integration testing means before integration testing, unit testing is conducted. Unit testing means a small unit of the project or program. If that unit testing is over, in that manner number of units are developed and they are tested, then those units, one or two units, are combined to each other. That combining we are saying as integration. So if we integrated and then we tested that one, it comes under integration testing. So integration testing is a big bang approach. In the integration testing, there are two different incremental integration strategies. Those are, first one, top down integration and bottom up integration. So these two are nothing but two different approaches of integration testing. So in that, the first approach, top down integration, means, so in top down integration, they given modules subordinates to the main control module are incorporated in the structure in either a depth first or breadth first manner. That means a top down integration. The top down integration means, so the main modules. So for example, I will show on the diagram. So top down integration means the main module, what we are treated as, we can say that one as a driver also. For the main module, the sub modules may be integrated, that means combined in top down manner. The flow may be from top to bottom. The integration flow may be flow from top to bottom. In that flow, we have two concepts are followed. One is depth first or breadth first. So what is meant by depth first or breadth first means, depth first means from top to bottom in one left hand side. The exact left hand modules are integrated from M1 integrated to M2 and M5 and M6. Afterwards M6, and then moves to the right hand side, M1 to M3, M7, then M4. So these types of approach is depth first, and breadth first means level by level. So M1 is integrated with the first level components M2, M3, M4, and then to second level components M5, M6, M7 are integrated. Then third level components M6. In this manner, level by level integration is carried out. Then this comes under breadth first. So these are the two manners we are following in top-down approach. So this is the diagrammatic concept of top-down approach. To follow this top-down approach, we must process and perform in a series of 5 steps. Concepts is there for top-down approach. So in that, first step is the main control module, that nothing but M1 is used as a test driver, and stubs are substituted for all components directly subordinate to the main control modules. So here driver is M1 and stubs are substituted. Here stubs means all these subordinate comes under. So this is the first point. Then depending on the integration approach selected, the second point, we want to select the integrating approach, either depth first or breadth first is selected, and subordinates, that means these modules or these stubs are replaced one at a time with actual component. So these modules are integrating with the main component one by one by based on the approach what you selected, either depth first or breadth first. Then after integrated, third step maybe comes under here. The tests are conducted on each component is integrated. After each component is integrated, you want to conduct a test. Then fourth step, on completion of each set of tests, another stub is replaced with the real component. If one set is combined, integrated, and testing is also over, then another step is replaced. That means another step is ready to combine or integrate with the actual component. In that manner, all the components or stubs, that means subordinates, are integrate with the main concept or main component. Then whenever each component is integrated, testing will be conducted, and finally all the components are integrated, then regression test may be takes place. Regression test may be conducted to ensure that any new errors have not been introduced. That means after completed the total integration, regression testing must be conducted for checking any new errors are there or not. So these are the steps we followed when making top-down integration. Then the second type is nothing but bottom-up integration. So in the top-down, integration carries from top to bottom. In the bottom-up, integration carried out from bottom to top. So for this one also, we are following some steps. In that, now come to the point. First point, the lower level components are combined into clusters. That means the lower components are combined to form a clusters. Clusters means sometimes called builds that perform a specific software sub functions. So the lower functions or lower components are combined to make a cluster, and for these clusters, in the second point, a driver, nothing but a control program for testing, is written to coordinate test case inputs and outputs. So we want after finder or combine the clusters, we want to define drivers. So drivers are nothing but control programs to coordinate test cases. Afterwards, these clusters, after defined the drivers, the third step, the clusters are tested. After completed the testers of these clusters, drivers are removed and clusters are combined, moving upward in the program structure. So after the clusters are tested, then the drivers are removed and these clusters are combined with that upper main programs, and here the same concept will be repeated again, and from here to the components are connected or combined or integrated to the uppermost components. So in this manner the integration takes place from bottom to top. So these are the two approaches in integration testing. So the other concepts in integration testings are regression testing and smoke testing. These two testings are also comes under integration testing. So in regression testing means regression testing is re-execution of some subset of testings that already conducted to ensure that changes are not propagated unintended side effects. The overall concept of regression testing means if once a project or a software or any component are developed, it is tested, all the unit tests is also completed and integration testings are completed, then if any modifications are occurred, if you change anything, if any side effects are there or not, to check that one, the regression testing is takes place. So this is the overall concept of regression testing, and this regression testing is also conducted manually by re-executing the subsets of all test cases are using automated captures or playback tools. So this is the concept of regression testing, nothing but re-executing all the subsets of the concept to check if there is any changes in the project or program. So this is the concept of regression testing. Then come to the second concept of integration testing, nothing but smoke testing. Smoke testing is an integration testing approach that is commonly used when product software is developed. So integration testing is carried out in once a product of software is developed to check the complete concept is nothing but smoke testing. So in smoke testing, some of the steps are followed. In that, the first step is software components that have been translated into code or integrated into a build. So in the first step of smoke testing, all the software components are translated into code and integrated into a build. A build means the total complete software structure is developed. So first step, so develop the software. Then second step, a series of tests is designed to expose errors that will keep the build from properly performing its function. So after the project or software is developed, a series of tests is conducted on that software whether all the functions are performing properly or not. This is your second one. Then third point, the build is integrated with other builds and the entire is smoke tested daily. So in that manner, one part of the software is developed, it must be integrated to another parts of the software, and that integration is daily checked entirely by using smoke testing. So these are the steps we have followed in smoke testing. So smoke testing means nothing but testing the entire system daily for finding out any errors. About this smoke testing, Mark Condell described in following manner. So that is nothing but the smoke test should exercise the entire system from end to end. It does not have to be exhaustive, but it should be capable of exposing major problems. The smoke test should be thorough enough that if the build passes, you can assume that it is stable enough to be tested more thoroughly. So that means McConnell described about the smoke testing in the manner of it is used to test entire system from one end to another end. It's mainly used to find out errors thoroughly and rectify them. So with the help of smoke testing, we can provide a number of benefits when it is applied on complex or time critical software projects. So what are those benefits means there are 4 different types of benefits are there. In that first one, integration risks are minimized. The first benefit of smoke testing is we can minimize integration risk. The second one, quality of the end product is improved. Always when we are conducting the smoke test on a software products, then the product of the quality is improved. Third one, error diagnosis and corrections are simplified. Then fourth one is progress is easy to assess. So these are the 4 benefits are there for smoke testing. So these are the concepts of testing strategies for conventional softwares. Then the second concept in today's video is test strategies for software object-oriented softwares. In this concept, we have 2 points. One is unit testing in the object-oriented context. And second one, integration testing in the object-oriented context. Then if you come to the first point, unit testing in the object-oriented context means always we must remember when we discuss about object-oriented programming, we must remember 2 points. One is classes and objects. So in this environment, each class may contain different objects and its packages, attributes and its different operating functions it may contain. So to testing each class In the object-oriented software, this comes under nothing but unit testing. Unit testing. So this is the concept of unit testing in object-oriented context. Then if you come to the second concept in test strategies for object-oriented software is integration testing in the object-oriented context. In integration testing of object-oriented context, we have three different strategies for integration testing of object-oriented systems. They are: first one, thread-based testing; second one, use-based testing; third one, cluster testing. If you come to the first testing, thread-based testing means integrates the set of classes required to respond to one input or event for the system. Each thread is integrated and tested individually. That means thread-based testing means we are integrating the set of classes to provide a response for one input or event existed in the system. That set of classes we are treated as a thread here, that each thread is integrated and tested independently. So this is the concept of thread based systems. Then come to the second strategy for integration testing of object oriented system is use based testing. Use based testing means construction of the system by testing independent classes that use very few server classes. This is called use-based testing. Then when you are constructing the system, when you are testing the classes independently, to test that classes independently, we are using very few server classes. So we are not using all the classes, we are using only few server classes. So we are testing those server classes only when it comes under use-based testing. Then third one is nothing but cluster testing. So cluster testing means it is also one of the step in integration testing of software systems. So in that, in object oriented system we having classes. So classes can related to one another is a concept called collaboration. So when you are collaborating the classes, they collaborate in homogeneous manner. If homogeneous manner they are collaborated, we are calling that one as a cluster. So testing of a cluster is comes under cluster testing. A cluster may contain collaborative classes. So testing that cluster comes under cluster testing. So these are the concepts of test strategies for object oriented softwares. It may contain unit testing and integration testing of object oriented construct. In integration testing we have three different types of integration testings. One is thread based, use based and cluster based testings. So these are the concepts of test strategies for object oriented softwares. Then we are going to discuss the third concept in today's video. Is nothing but test strategies for web apps. So you already know when you are developing web application softwares, we need to follow some of the testing strategies. We need to test different modules. So they are how the testing strategies for web applications are given in principles manner. So when you want to test the web applications, we have basic principle concepts. They are given here. In that, the first one, the content model for the web application is reviewed to uncover errors. So first point is whenever you are testing the web applications, we want to test the content model for the web application to review any errors are there. Then second one is interface module is reviewed to ensure that all use cases can be accommodated or not. So the second point, interface modules wants to tested. And in the third one, design module for the web app is reviewed to uncover any navigation errors. In the third step, we want to test design modules of the web applications to find out any uncover navigation errors are there. In the fourth step, we are testing user interfaces to uncover errors in presentation or navigation mechanism. So we want to test the user interface also. In the fifth step, we want to test all the functional components in unit tested manner. So all the functional components also want to test of the web application. Then sixth point, navigation throughout the architecture is tested. In the web application, what are the navigations are there? It must be thoroughly tested. Then seventh, web app is implemented in a variety of different environmental configurations and is tested for compatibility for each configuration. So web application, the third point explains the web application may implemented in different environmental configurations. It is web application may not be developed or implemented for a single configuration or single environment. It is developed for supporting variety of different environmental configuration. Those also wants to test it, and each configuration compatibility, whether they are suitable to each configuration, whether the compatibility also wants to test it. That is the seventh point. Then eighth point, the security tests are conducted in an attempt to explore vulnerability in the web app or within its environment. The security of the web application also want to test it. It is discussed in 8 point. Then performance of the web applications also want to tested. It is in 9 point. Then the 10 point says the web app is tested by a controlled and monitored population of end users. So finally, the web application wants to test by the end users also. So these are the 10 points which says the testing strategies for web applications. So today in this video we discussed the concepts of test strategies for conventional softwares. It contains unit testing and integration testing concepts. In the integration testing, we have top-down approach and bottom approach, and integration may contain regression testing and smoke testing. And the second concept called test strategies for object-oriented softwares, it contains unit testing and integration testing. Then the third concept is test strategies for web applications. These web application test strategies are explained on the basis of some principles, 10 basic principles. So based on these three concepts, some assignment questions are given here.